Thank you, Gisela. It was great. Thank you very much. As you know, we collected every year, thanks to our survey, all the information, the trends, and the concern about the Kubernetes engineers. And according to our survey this year, we understood that deploying databases in Kubernetes is still a concern for all the engineers, right? So that's why I'm very excited about the oncoming talk from Paulo and Shayan. They will explain to us how to do D2 operations, such as scaling, backup, things like that. And then we will see how MySQL can be deployed on Kubernetes and how it can be operated. Thank you. Go ahead, Pablo and Shayan.
Hello, everyone. Thank you, Cedric. So now we are presenting data on case with MySQL, a Dolphin style. So let's start. I am Paulo Machado, Senior Engineer in the Data Platform team. And our first topic will be high availability with the MySQL Charmed operator. So how do we achieve high availability with the MySQL Charmed operator? Basically, we are using one plugin called replication that is done by MySQL team, which allows the clusterization of MySQL. So this is synchronous data replication. And also to leverage the full high availability, we deployed together with the setup MySQL Router instance. So the MySQL Router, it is a database proxy that will hop between connections and sit between the application and the MySQL nodes in a cluster. So an application will connect to the router and have different ports for either primary connection or read-write and read-only connection, so dedicated ports for each. The information that are needed to the operators relate itself are all transmitted within UG relations. So things like database name, credentials, Astra user roles. For instance, MySQL Router requires some Astra user roles in order to bootstrap itself before becoming the database proxy. So there's no better way to do it with a demonstration. So let me spawn my demonstration and we can exemplify all we are doing here. So we'll start with the addition of a new model. So we have already an operator, a controller deployed here, a microcase controller, and we add a new model to it. And then we can right away deploy the MySQL charm from Channel Edge, and we see what's going on. So spawning some tmod section, and we can take a look at status. So at this point, we are deploying just a single unit. And as you can see, Juju is installing its agent. It loaded the container already. So the charm code right now is setting up a single node cluster. Take a little bit. So after a little time, it's already active, and we can take a look at the actions configured by this operator. So actions are a way to interact with the operator, and I have get cluster status. So let's check it out, the status as reported by MySQL. We wait for the output. Yeah, that's not very readable. Let's take a look with a simple IQ filter to add some color and just get there what we want to see. So you can see the cluster topology just contains a single node and with the member role as primary and mode read write. So that's what's expected when you deploy just one node cluster. It's even though it is a clusterized application, but it doesn't have any fault tolerance. So for having fault tolerance, we should scale it out. So use scale Juju, scale application to the number of units, and we wait until we have 3 pods initialized, and the operator code will take care of adding each pod to the running cluster. So let's take a look. Meanwhile, just get the root user password so we can use later on. So I'm storing this on another. Okay. So now you can check in the state of it. we can see that the node is already active with 3 nodes. And let's take a look at the status again. Running the same, we can see now we have the topology with 3 nodes within the cluster. So the first unit, MySQL Case 0 is still the primary, and you can see nodes 1 and 2 are now as secondary, so as a read-only mode. And to test it out, Juju report status. To test it out, fault tolerance, let's kill the primary code to make things more interesting. So K is just an alias for kubectl. Operator is the model name, also the namespace name. And we kill the primary pod. So at this point, Juju is taking care, actually, Kubernetes is taking care of reschedule the pod, and Juju is monitoring it. And you can see unit 1 is already the new primary, so we got a re-election within the MySQL cluster. Checking the topology again, we have to run it from a running instance. We can see that, again, the primary role is on MySQL Case 1 now, and MySQL Case 0, the first unit was the former primary, is now in secondary mode, is still in recovery, so it's being added to the cluster. So right now I can see the status is supported maintenance, and it should be back on the cluster again. So now checking the status output, you can see it's already on secondary member role with mode read only, and the primary is still on the new unit. So this is just MySQL as a standalone application. Now we can test it with addition of the MySQL router, so the proxy for the database. And also for this presentation, we have a test application. So we can see it as any application, let's say a WordPress or something like that. So MySQL router will stand in between MySQL cluster and the test application. And we relate them accordingly. So MySQL router is related to both the MySQL application and also the test application, just identified as app. So at this point, Juju is receiving events from the relations and acting accordingly. So exchanging credentials, creating users, and all of that. So let's take a look with spawn MySQL shell access to the nodes in the database to check what's going on there. So the test application, it will start by default continuous writes to special table, and we can check if it's being writing to. So this is the first unit, MySQL 1, and you can check, take a look that we have a continuous write database data table being written to. So let's take a look at the other IP from the second unit. And there you have it, another value. So the value is incrementing because the application is continuously writing. So that's why we won't see the same value. And in the third one, you can check it out just a second. Get the IP. Get the command. As there we have it. So another incrementing value. So if at any time required, you have a different value. So just to check replication, the single replication, you can run an action in the test application that will stop the continuous write. So you can take a look to a static value. Let's do just that. Now you can see across all instances, we have the same value replicated. Cool. We can check also the the same query, but running through the router. So let's change the IP address to the one from the router exposes. And the difference is the default port for the MySQL router is different because we have, as I said before, dedicated port to the read-write and dedicated port to the read-only. And you can check the same query through the router, hence the same value. And that's how we achieve high availability with MySQL Charmed Operator. Next topic would be encryption in transit. So how do we enable encryption between MySQL peers, MySQL clients, and MySQL router? In the Charm ecosystem, we have a very handy charm called the TLS certificates operator. So the TLS certificates operator provides certificates for any given operator that implements its interface. And in the case of MySQL cluster, it also enforces encrypted connections from the clients. Encrypted connections between MySQL peers are handled by default. So every group replication connection is encrypted by default using MySQL communication stack. That's what we are using there. And by default, the MySQL server does not enforce encryption. So it suggests if it's not explicitly configured by a client, it will enable encryption, but if not, it can allow unencrypted connections. So let's check it out how to do that again with a quick demonstration. So using the same deployment that we used before, we can test it out that in fact we can connect without encryption. So passing this option to MySQL shell, SSL will disable. You can see that SSL field is not in use. So MySQL, it will still allow unencrypted connections. As you can see here. So next step would be the deployment of the TLS certificates operator. And to ease things out, we can pre-configure the TLS certificates operator to generate a self-signed certs and passing some dumb cert name. The TLS certificates is very, very low weight, very lightweight, so it's very fast to deploy. And we can already relate to MySQL Kate. So we have TLS already deployed, relations being settled, and yep, TLS must be in place already. So let's try connection and encrypt it again. And then you can see we have an error informing that the required security support is on. So MySQL keys operator, it's already enforcing only secure connections. And if we try a secure connection by removing the flag, we can have the connection, checking status again. You can see there is a cipher in use. And that's it for me. Now I hand over the presentation to my colleague Shayan.
Yes, thank you, Paulo. I'm Shayan. I'm on the same team as Paulo. We both work on the MySQL operators. So I'm going to talk about backups and restores in the MySQL Kates operator. So we currently support backups and restores, but backups need to be created on a replica unit. This is so that if there's a primary unit, it can continue to serve traffic while one of the replicas will sort of detach itself from the cluster, from any incoming traffic, and create the backup. However, if there's only one unit, then it's the primary, then we allow that unit to create the backup while serving traffic. This may lead to degraded performance, but there's no other option. We can also sort of restore, we have an action to look at the list of compatible backups that we can restore on the unit. And these backups are physical backups, so they are not logical backups. They copy over all the files from your running instance into any S3 compatible interface. This can be AWS, GCP, MinIO, or Ceph. And as a bonus explanation, we're using Percona's XtraBackup tool to create these backups. We run this backup command with XtraBackup, and then we use XB Cloud, which is a toolkit, a tool in the XtraBackup toolkit that will put the backup files in S3. So for restores, we can restore the backups we created on an existing cluster or a new cluster. However, because it kind of is like inherent in the nature of restores, we need to scale the application down to 1 unit. And this is so that there's no like conflicts while it's restoring. You can't really have a cluster up while a restore is taking place. So we scaled down the application down to 1 unit, rotate any passwords if we need to rotate passwords, if it was created on a different cluster, and we run this action to restore a backup. We currently use XtraBackup to restore as well. We use XB Cloud to retrieve the backup from S3. XtraBackup prepare, since the backups are not point in time consistent, you need to run this XtraBackup -- prepare command to basically make the backup point in time consistent, and then you run XtraBackup move backup to move the files from the temporary directory where you retrieve the files to and into the data directory from MySQL. So we have a little demo. So I don't know if you can see, but at the top here in the video, we're starting about deploying MySQL. And we specified the channel. Currently, it's latest edge. We will be promoting this edge channel to a beta and a stable candidate soon. We also have to deploy this S3 integrator charm, which is kind of like the TLS operator charm. It's where the S3 integrator charm is where we will supply all the S3 credentials and like bucket name, which we will pass as a config, and the path within that bucket where we want to store backups. So here's the bucket name, MySQL Backups Development, which is a bucket I created. And we want to store all the backups in this test path in that bucket. So we pass in the bucket name and the path as config options. However, we need to pass in the secret and the access key in a more secure fashion and not configs. So we run this action called sync S3 credentials. And we pass in the access key and the secret key to S3 credentials, or sorry, S3 integrator. Once S3 integrator has all the information, we relate MySQL K8s and S3 integrator. And through this relation, S3 integrator will be passing all the S3 information that MySQL K8s needs to create a backup and restore backups through the relation. So now that we've related, let's look at what backups we have available to us. So we can do that by running this list backups command. And we can see that there are no backups because we haven't created any. So before we create a backup, let's get the root password. Now that we have the root password, we can log into the container of the pod, the MySQL K8s pod, and we will run MySQL sh with a SQL shell on that container. So we'll look at the databases. Those are all the system databases. And we'll create one. We'll call this test before backup. What the idea is that we'll create a table before backups, take a backup, and then we'll by mistake drop this database, and we'll make sure that we can restore back to it. So now we have test before backups as the database. So let's create a backup. To do that, we run this action called create backup. Since we have one unit, we run it on the primary. If we had multiple units, we would have to run it on a replica. So now we have a backup ID, and if we look at list backups again, it will no longer be an empty list. There's a backup ID. So now let's say we created a backup, and then we ran some queries which we weren't supposed to run, like drop this database. So we dropped this database by mistake. And then we created another database by mistake. I don't know how you can do that, but you do. So when you look at the databases, and like we will have test after backups as the only database that we've created. And we don't want that. We want to restore our backup. So we will run this command run this action called restore. And we'll pass in the backup ID of a valid backup from list backups output. So this is that ID that is up there, just above it, and we'll restore. And while it's restoring, it sort of shuts down MySQL, the copies over files. It runs all those XtraBackup commands that we talked about. And then it starts up MySQL again. So now if we look at the database, we should see that we should have restored, and our database that we had so conveniently dropped is back there. And that's our demo. And as a final thing, we have this gist where you can find all of the commands that we have run, and we encourage you to try and like give us feedback. You can provide feedback on our repositories; they're all open source. And yeah, thank you. I'll hand it back to Cedric now.